Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us to the edge of everything, or at least to the farthest edges we've ever managed to see. We'll drift together through the stories of our greatest eyes on the universe, telescopes and travellers that reached across the darkness, gathering light that has travelled for billions of years just to meet us here. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey to the edge of everything together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Let's begin close to home, in the quiet hum of human invention. There was a time when the most ambitious mirror ever built had to be folded, like a metal flower, to fit inside a rocket. It had to survive the shaking of launch, the silence of space, and then, like a blossom in slow motion, unfurl perfectly, petal by petal, a million miles away from home. That mirror was the heart of the James Webb Space Telescope, a fragile promise made of gold and precision. For decades it had existed mostly as hope and anxiety. Engineers whispered its numbers like a prayer, a mirror 6 times larger than Hubble's, built from 18 golden hexagons, each so light that even a human breath could flex its edge. The shield that protected it from sunlight was the size of a tennis court, layered in 5 thin sheets no thicker than a human hair. Everything had to open in perfect choreography, and there were hundreds of steps that could go wrong. Tiny motors, pins and latches that had to behave flawlessly after travelling through fire and vacuum. And yet, it worked. Against odds, against fear, it bloomed. When the first rays of sunlight struck those mirrors, still cooling toward absolute zero, it was as if an instrument older than time had finally taken its first breath. Infrared, that's what it sees. Not visible light, not the colours our eyes can hold, but the longer, softer waves of warmth. Because as the universe expands, the light of the earlier stars stretches, becoming fainter and redder, like the echo of a song drifting down a hallway. JWST was built to hear that echo, to look not at what shines now, but at what once was, the faint glow of the first dawn. We often think of telescopes as cold machines, but there's something very human in their purpose. They're our way of reaching without moving, of asking in the quietest way possible, what else is out there? And the Webb telescope, in its patient stillness at a place called L2, a point of balance where the gravity of Earth and the Sun cancel out, became our newest eye in the dark. When it sent back its first image, the world stopped for a breath. It wasn't just a picture, it was a window that had been locked for 13 billion years. A field of galaxies, thousands of them, glowing softly through the distortion of space-time itself. Each one a city of stars, some so far away that their light began its journey before our sun was born. The patch of sky it captured was smaller than a grain of sand held at arm's length, and yet within it lay uncountable worlds. Think of that for a moment. All that light, all that history contained in a patch of nothingness you could cover with your fingernail. It's humbling, isn't it? We build something fragile enough to need sunshades thinner than paper, launch it across emptiness, and in return it shows us time itself. And yet, the wonder of it isn't in the numbers or the precision. It's in the silence between the discoveries, in the realization that the universe has been patiently waiting for us to look this far. If you listen closely to the data, it sounds almost like music, infrared melodies of hydrogen and helium, the two simplest notes in existence. They hum through the instruments as faint electrical patterns, but what they really carry are memories, the glow of the first stars igniting, the first atoms meeting in the cold. There's poetry even in the engineering. The mirror's petals, each coated with a whisper of gold, had to align so perfectly that the difference between them was smaller than the width of a virus. Yet in that alignment, they captured the breath of galaxies. We sometimes forget that all of this was made by hands, by people who stayed awake through nights of testing, who worried about bolts and batteries, who argued gently over decimal points. It's easy to see science as cold, but there's warmth behind every calculation, a quiet kind of devotion. When the telescope finally saw its first star, a single bright point in the vast blackness, the team back on Earth didn't cheer loudly. Many of them cried, because in that light was proof that everything had unfolded just as planned. After all the years, all the doubts, the universe had opened its hand and offered us a spark. If you could stand beside it now, drifting in that silent orbit, you wouldn't hear anything. But you might feel it, the gentle warmth of sunlight caught and filtered, the absolute stillness of something doing exactly what it was made to do. It faces away from us, always pointed toward infinity, collecting light that will outlast every human life that built it. In a way, the Webb telescope is not just looking outward, it's looking backward, toward beginnings, toward the slow unfolding of everything we've ever known. And so, our quiet journey begins with that bloom of gold, turning its gaze toward creation itself. The story it tells next will take us deeper still, beyond clouds of birth and into the radiant heart of the stars themselves. If we follow the thread a little further, our journey drifts from the telescope itself to what it began to see once its eyes adjusted to the dark. The first of those sights was something that almost feels alive, a vast wall of gas and dust rising like cliffs of glowing smoke. The image was called the Cosmic Cliffs, a name as soft as the view itself. It lies inside the Carina Nebula, a region where stars are being born even now, quietly, steadily, beyond the reach of human time. Imagine looking through a fog so dense that no visible light could pass through it. For centuries, that fog hid the earlier stages of stellar birth. The Hubble Space Telescope, for all its gifts, could only see the surface, like looking at the face of a cloud lit by lightning from behind. But Webb's eyes, tuned to the faint warmth of the infrared, could see through it. To Webb, the dark dust became translucent, revealing stars still in their infancy, glowing like embers under blankets of cosmic soot. The cliffs themselves aren't cliffs at all, of course. They're sculpted by radiation, winds of energy streaming from young, hot stars just above the cloud's edge. Over millions of years, those winds carve the gas into spires and valleys, towering structures light years tall. If you could stand there, you'd see colours we have no words for. Hydrogen glowing pink, oxygen breathing in pale blue, and carbon dust catching golden light like fog at sunset. Every tendril in that image is a story in progress. Within the densest knots of gas, gravity is quietly gathering atoms together, squeezing them until they ignite. Each spark will one day become a sun, maybe with planets, maybe even with oceans. Somewhere in that cloud could be another world waiting for its dawn, still cocooned in the gentle weight of dust. There's something tender about it, isn't there? The idea that stars, those blazing furnaces we think of as eternal, begin life as fragile things, hidden, shivering, barely alight. In time, their warmth will push away the clouds that protect them. The same radiation that gives them shape also erases their cradle. Creation and destruction in one continuous breath. In the cosmic cliffs, Webb found details that had never been seen before. Threads of gas curling like smoke rings, tiny shockwaves where newborn stars first exhale their energy. The telescope captured the delicate outlines of jets, narrow streams of material shooting from the poles of these forming stars at hundreds of kilometers per second. To describe that speed more gently, think of it this way. If a newborn star were blowing out its breath, it would sweep across the distance between Earth and the Moon in less than a day. Yet Webb's instruments saw it not as motion, but a structure frozen in light, and there, within one of the darkest pockets, Webb caught something precious, a cluster of very young stars, still surrounded by their dusty disks. These disks are the raw material for planets. When we look at them, we're seeing the universe in rehearsal, practicing the act of creation again and again. Our own sun once passed through such a stage, wrapped in dust, spinning slowly as gravity sculpted its companions. Somewhere in that cloud of ancient gas, the atoms that now form our oceans, our bones, and even the telescope itself were already being mixed and stirred. That's the quiet miracle of astronomy. The light from the Carina Nebula took about 7,500 years to reach us, older than the pyramids, older than every story ever written. And yet, what we see in that light isn't history alone, it's continuity. The same chemistry, the same physics, repeating themselves in endless patterns of renewal. There's a gentleness in the way Webb shows us this, not with fanfare, not with noise, but with patience. Each wavelength of infrared light tells a different part of the story. The shorter ones, nearer to the red edge of what our eyes can see, reveal the outer clouds. The longer ones reach deeper, tracing warmth from within. Together they make a portrait not of chaos, but of balance, the universe breathing in and out, light and dust in conversation. When the first image of the cosmic cliffs appeared, it was almost easy to forget it was real. The structure looked painted, as if a giant brush had swept through space. But it's not artifice, it's physics written in beauty. The same pressure that forms storms in our atmosphere sculpts these cosmic landscapes. Only here, the scale is measured not in miles but in years of light. Astronomers studying the Carina Nebula often speak of it like a living thing. It evolves, collapses, reforms. In human terms, it's as if you could watch mountains grow and melt in the same lifetime. Webb's image froze one heartbeat of that transformation, and within that stillness lies movement too slow for us to witness directly, but steady enough to be certain. The universe is always changing, even when it looks perfectly still. If you look at the image long enough, it almost seems to move on its own. The eye follows the bright ridges upward, then down into the darker valleys, like tracing waves frozen in mid-motion. Perhaps that's part of its magic. It invites you not to learn, but to linger, to simply notice how everything that feels distant can also feel familiar. The light, the dust, the quiet pull of gravity doing what it always does, gathering, shaping, giving form to possibility. There's a saying among astronomers that looking at starbirth is like looking at our own reflection, stretched across space and time. Every atom of carbon in our breath, every molecule of iron in our blood was once inside a star like those being born behind the cliffs. When you gaze at that glowing wall of dust, you're seeing the first chapters of your own story, written in starlight, waiting to be read. And so, our quiet exploration lingers there for a moment, in that nursery of stars before drifting gently onward, to where some stars begin their final transformation, releasing their beauty into space one last time. As we drift further into the story, the light from those newborn suns begins to fade behind us, replaced by something softer, more delicate, like the glow of a candle nearing its end. In the quiet distance of space, there are places where stars have reached the end of their long burning lives. But rather than going dark, they leave behind shapes so gentle and radiant that even their final breath becomes art. One of these is called the Southern Ring Nebula, and when the Webb telescope turned its golden eye toward it, it found a cosmic afterimage so intricate that even silence seemed to pause and watch. From Earth, this nebula looks like a tiny ring of mist, an oval of light surrounding a fading centre. But Webb revealed that it is not a single smooth bubble. It's layered, textured, woven with filaments of gas like threads of silk. In its heart lies a small, dim star, one that has exhausted the fuel that kept it shining for billions of years. When such a star runs out of hydrogen, it doesn't explode in violence like the heavier giants do. Instead, it swells into a red giant, shedding its outer layers slowly, like a tree letting go of its leaves in the wind. The Southern Ring Nebula is what remains of that quiet surrender. Its glowing shell stretches across light years, expanding outward in waves of colour that our eyes can barely imagine. Webb's infrared vision pierced through those translucent layers and found not one star but two, dancing together at the centre, locked in a final elegant waltz. The dimmer one is the dying star, the one weaving this luminous cocoon. Its companion still burns bright, illuminating the clouds its partner has released. Together they've shaped the gas into intricate patterns, sculpted by their gravity and motion. To see this through Webb's instruments is to witness both an ending and a partnership. The gases glow with element forged during the star's life. Carbon, oxygen, nitrogen, all drifting outward, destined to become part of something new. It's strange to think that death in space can look like creation, but that's exactly what this is, a return of matter to the cosmic sea. In time, those drifting atoms will gather again, forming the next generation of stars, the next round of planets, perhaps even the heir of another living world. Astronomers often call nebulae like this planetary, though the name is misleading. It came from the early days of telescopes when their round shapes reminded observers of distant planets. In truth, they are anything but solid. They are made of almost nothing, so thin that a single puff of breath on Earth holds more atoms than an entire cubic mile of the nebula. And yet, in their emptiness, they shine. Webb's view revealed fine details never seen before. Faint arcs curling outward like the ripples of a pond, knots of gas clinging to the edges, and hidden structures within the central glow. Through mid-infrared light, astronomers could see the heat of the dust itself, glowing faintly where radiation warmed its surface. It is light born of warmth, not fire. A quiet reminder that even in the coldest places there is energy moving gently outward. If you could float there, drifting near the edge of that luminous shell, you would see colours unlike anything on Earth. The gases would shimmer in every direction, soft teal and amber, lilac fading into rose, each hue a trace of a different element, each line of colour a memory of the star's life. The air, if it could be called that, would be thinner than thought. You wouldn't feel the motion of the expansion, but you would sense it in the way light bends and shifts around you, a slow, graceful pulse that has been spreading for thousands of years. There's a profound calm in this kind of death. The star does not rage, it simply lets go, one layer at a time, releasing what it no longer needs. And in doing so, it becomes visible in a new way, not as a source of light, but as a painter of it. Each shell it casts off catches the glow of its partner and turns it into colour. It's as though the universe is saying that even endings have their own kind of radiance. This quiet farewell teaches us something deeply human. We too are made of things that once belonged to dying stars. The oxygen we breathe was exhaled by such giants. The iron in our blood was forged in cores that collapsed long ago. When we look at the Southern Ring Nebula, we are looking at our origins told in reverse, the way matter leaves one life to begin another. It's not a tragedy, it's a return. And Webb, with its delicate instruments cooled to temperatures colder than any winter on Earth, captured that story not with sound or words, but with light alone. It turned invisible warmth into images we could hold, allowing us to see beauty where before there had only been the unknown. Sometimes people imagine the universe is empty, but that's never quite true. Even here, in this moment of stellar death, space is alive with motion, atoms colliding, light scattering, dust drifting with the faint whisper of momentum. If you close your eyes and listen with your imagination, you might almost hear it, the slow sigh of a star releasing itself into the dark. There's a serenity to that image that stays with you. The dying star doesn't resist its fate. It becomes part of something larger. Its light softens, its colour spreads, and what was once a single brilliant point becomes a whole sky of texture and hue. The Southern Ring Nebula reminds us that in the vast conversation between birth and death, neither has the last word. Each transforms into the other, endlessly. As the light from that nebula reaches us across 2,000 years of distance, it carries not sorrow, but peace. A peace that comes from continuity, the understanding that nothing is truly lost, only changed. And so, as our gaze lingers on that soft oval of colour, we begin to see the rhythm beneath the silence. Stars being born, stars fading away, the same materials flowing in endless circles. From here, the story opens into the wider sky, where entire regions of creation blaze with the energy of a universe in full bloom, a place where starbirth becomes a storm of light and motion, unlike anything our eyes have ever known. The path now carries us toward a region where creation moves from whispers to thunder. It is a place where stars are not born one by one, but by the thousands. A luminous storm so fierce that even the darkness seems to glow from its edges. Astronomers call it the Tarantula Nebula. It lies in the Large Magellanic Cloud, a small companion galaxy just beyond our own, about 160,000 light-years away. But numbers don't really do it justice. To the eye of the Webb telescope, it looks alive, a maze of filaments, stretching and curling like the legs of its namesake, woven with gas and fire and motion. The tarantula is more than just a nebula. It's a snapshot of what our galaxy might have looked like when it was young and wild, during what scientists poetically call the cosmic noon, the universe's most creative period, when stars were forming faster than at any time before or since. To look at it is to look back at an era when galaxies glowed brighter, when gas flowed freely, and when the future of light was being written in real time. Webb's vision brought this storm into focus with a kind of tenderness. Where earlier telescopes saw a blur of brightness, Webb saw structure, a landscape of winds and pressure, with clusters of stars shaping the clouds that once gave them birth. The radiation from those stars pushes the surrounding gas outward, carving out hollows and caverns where new stars are beginning to emerge. It's like watching the sea sculpting its own shores, only here the waves are made of light. At the centre of this turbulent expanse lies a young cluster called R136, a gathering of massive luminous suns, some hundreds of times heavier than our own. Their light is so fierce that if you could stand on a planet nearby, though none could exist there, you would see the sky filled with blazing points brighter than any noon. But even those colossal stars are fleeting. They burn through their fuel in just a few million years, a heartbeat by cosmic standards, and then they explode, sending their elements far and wide to seed the next generation of worlds. When Webb looked into this region, it didn't just capture light, it captured time flowing in both directions at once. You could see stars being born at one end of a cloud, and at the other, remnants of explosions that happened long ago. Every bright knot and shadowed curve told part of the same story. Creation and destruction entwined, inseparable, each feeding the other. In the longer wavelengths of infrared, the nebula reveals its hidden scaffolding, dense filaments of cold gas and dust where future stars are still forming. In the shorter ones, the older stars burn through the haze, shining blue-white through the red mist. The contrast is stunning. Hot and cold, bright and dim, young and old, all folded together in a pattern so complex it looks like breathing. Webb's instruments turn that pattern into something we can see, translating invisible heat into visible grace. There's something deeply human in that act of translation. We've always found beauty in contrast, in the play between shadow and flame, silence and song. The Tarantula Nebula is the universe's own version of that balance. It's the loudest kind of beauty imaginable, and yet it moves with purpose and rhythm, like a symphony that never stops composing itself. If you could float inside it, the view would be almost unbearable in its brightness. The light from newborn stars would ripple through the dust like sunlight through water. The air, if we could call it that, would be thinner than a whisper, but it would shimmer with charged particles dancing through magnetic fields. The glow wouldn't be a single colour, but a vast shifting blend. Roses and ambers and silvers melting into one another, an ocean of luminous smoke. Webb's image of this region also shows something subtle but profound. The intricate filigree of hydrogen gas being ionized by ultraviolet light. In gentler words, the energy from the stars strips away the outer layers of atoms, making them glow. To our eyes, it looks like lacework made of fire. And yet this violent process is also what clears the space for new stars to shine. Chaos giving birth to clarity. That too seems to be the rhythm of everything. The Tarantula Nebula reminds us that even on a cosmic scale, creation isn't peaceful. It's noisy, messy, and magnificent. Gravity pulls, radiation pushes, and out of that eternal argument comes form, clusters, filaments, the spiral arms of galaxies. The universe doesn't rush, but it never stops moving either. Every collapse makes way for a spark. Every explosion leaves behind the ingredients for something new. The scientists who first studied this region often described it as a laboratory of extremes, but Webb has changed that language. Now, we can see the delicacy within the violence, the way the edges of the gas clouds curve softly, the way filaments intertwine like threads of hair caught in wind. The harshness dissolves into intricacy. It's not chaos, it's choreography. In some sense, we're looking at our own origins, just written in a grander hand. The dust here is made of carbon and oxygen, the same elements that later built the molecules of life. Somewhere long ago, material from a place like this condensed into the sun, into Earth, into the warmth that fuels our hearts. We are not separate from that nebula. We are its continuation. When you gaze at its swirling arms, you're seeing the childhood of everything that will ever breathe. There's comfort in that idea, that even the most immense violence of the cosmos leads eventually to harmony. The Tarantula Nebula is fierce, yes, but it's also generous. It spends itself freely so that light can exist elsewhere. Its beauty lies not in its calm, but in its persistence, the way it keeps building, shining, dissolving, and rebuilding again. As Webb gathered its images combining wavelengths and exposures, what emerged wasn't just science. It was a reminder that the universe is still busy being young. Despite its billions of years, it hasn't grown tired of creation. There are still nurseries, still storms of birth, still waves of radiance moving through dust. The cosmos, in its own slow language, keeps saying, "I'm not finished yet." And from the brilliance of that statement, we now begin to drift outward, away from the bright nurseries and the newborns, toward places where light is older, stretched thin by distance, bent by gravity into arcs and echoes. The path ahead leads us from creation into reflection, from what burns to what remembers. From the shimmering storm of the tarantula, our view drifts gently outward, past clouds, past clusters, into a place where stars no longer act alone. Here, gravity conducts a slower, grander dance. Whole galaxies sway toward each other, their arms outstretched in spirals of starlight. collisions that take hundreds of millions of years play out like a waltz frozen in time. One of the Webb telescope's first portraits of this cosmic ballet was something called Stephan's Quintet. 5 galaxies bound together in a delicate, destructive embrace. At first glance, it looks almost peaceful, as though they are posing for a family photograph. But look longer, and you can feel the tension in the image. Tendrils of gas twisting between them, shockwaves of light where their edges meet. Each galaxy holds billions of stars, and yet gravity tugs at them as though they were drifting leaves caught in the same slow current. Webb's instruments captured not only the galaxy's glow, but also the faint warmth of the dust between them. That dust, invisible to ordinary eyes, carries the fingerprints of creation, carbon, and silicate grains that will someday form new stars. The infrared light revealed swirling filaments of gas heated to thousands of degrees, arcing like rivers of molten glass. In one region, where 2 galaxies collided head-on long ago, Webb saw a shockwave stretching for tens of thousands of light-years, glowing in shades of gold and amber. If we could translate those colours into sound, it would be like the deep hum of cellos, long and resonant, filling the space between notes. The galaxies aren't destroying one another so much as blending, merging, exchanging. Every collision creates turbulence, yes, but also renewal. The gas compressed by these encounters can collapse into new generations of stars. Even in what looks like ruin, the universe finds a way to begin again. Stephan's Quintet has another layer of wonder hidden within it. Of the 5 galaxies, 4 truly share this gravitational dance, while the 5th, though it appears to be among them, is actually much closer to us, a bystander seen in the same line of sight. It's as though we're watching a cosmic play, and one of the actors is standing much nearer to the stage lights, giving the illusion of belonging. Webb's image captures this perfectly, showing the illusion and the reality woven together. To see this with your own eyes is to feel the scale of motion that surrounds us. Galaxies drift, collide, and reshape themselves across billions of years. Yet in this still frame, frozen by light, we see both movement and memory, a pause in the dance that allows us to study the choreography of time. But Webb's view didn't stop there. Not long after Stephan's Quintet, it turned its gaze even deeper, beyond single galaxies, beyond clusters, into a patch of sky so small it could fit beneath a grain of sand held at arm's length. It was here that Webb captured what NASA called its first deep field. At first, it looks like an abstract painting, specks of light scattered across blackness, streaks and arcs bending in graceful curves. But every single one of those specks, every curve and smudge is a galaxy, some so far away that their light began its journey when the universe was only a few 100 million years old. In that single image, there are thousands of them layered across time. It's difficult to imagine distance on that scale, so perhaps it's easier to think in terms of light. The glow reaching us from the faintest of those galaxies has been travelling since long before Earth formed. Each photon, a particle of light, has been stretched by the expansion of the universe until it reached the infrared wavelengths Webb was designed to capture. What Webb saw was not the present universe, but its childhood. Among those faint red smudges, astronomers discovered some of the oldest known galaxies, tiny compact structures filled with young stars. The most distant of them glowed softly. Their colour shifted so far into the red that to our eyes they would be invisible. But Webb's sensors could feel their warmth, could translate their ancient light into something we could see. It's like listening to a song that's been echoing for 13 billion years and realising you were the first to hear it again. Gravitational lensing made this miracle possible. In the centre of the image sits a massive cluster of galaxies, its gravity bending space around it. The light from far more distant galaxies passes through that curved space, stretching into arcs and rings. It's as if the universe itself has become its own telescope, magnifying the unreachable. Webb's instruments turn those distortions into windows, each arc a glimpse of something otherwise too faint to see. The result is not just an image, it's a time machine. The first deep field shows us galaxies as they were when the cosmos was less than 1 billion years old. Some are clumpy, irregular, still forming their first structures. Others already show hints of spirals, foreshadowing the grand shapes we know today. In their tiny red forms, we see the blueprint of everything that came after. What's most astonishing is how quickly Webb achieved this. The image was gathered in less than a day, a handful of hours of exposure. Hubble in its time had taken weeks to reach similar depths. It's not a competition, but a continuation, the passing of a torch from one eye to another, each revealing more of the same story. When the image was unveiled, many of the scientists who built the telescope spoke softly, almost reverently. They had spent decades working toward this moment, yet when it arrived, the overwhelming feeling wasn't triumph, it was stillness. To see so much contained in something so small was to confront the quiet enormity of the universe. It's humbling, this realization that even the darkest patch of sky is overflowing with light. There are no true voids, only distances we haven't bridged yet. Each point of a light holds its own history, its own suns and planets, perhaps even its own watchers looking back at us through another deep field of their own. The first deep field changed not just what we know, but how we see. It reminded us that every moment of observation is also a moment of reflection. When we look outward, we also look inward, measuring not just distance but desire. The desire to understand, to witness, to belong. And as the light of those galaxies reaches us stretched thin but unbroken, it whispers a truth both vast and gentle, that even across billions of years, light remembers its way home. From here, our quiet exploration will follow that light beyond the reach of any telescope, past the boundaries of our instruments and into the memories of another great eye, the one that first taught us to see this way and still keeps watch from orbit, the Hubble Space Telescope. Our trail of light carries us now toward an older eye, one that has been watching from just above the breadth of Earth for more than 3 decades. Before the Webb telescope unfolded its golden wings, there was another sentinel circling quietly through the upper night. Its mirrors were smaller, its instruments simpler, yet its vision changed everything. The Hubble Space Telescope, a name that feels almost familiar now, was humanity's first great brush dipped into the canvas of the universe. If you could stand beside it, you wouldn't hear a sound. It orbits 500 kilometers above Earth, moving fast enough to circle the planet every hour and a half. Below, the blue curve of our world turns slowly. Above, endless black. Against that silence, Hubble has been painting light since 1990. Patient, tireless, its gaze steady as the generations beneath it have changed. When the telescope first opened its eyes, the images came back blurred. A tiny flaw in its mirror left the stars smeared, like tears across glass. For a moment it seemed that a dream had failed. But then came a repair mission, astronauts floating in silence, working by hand in the vacuum, giving the telescope new lenses, a new heartbeat. When the next images arrived, sharp and radiant, humanity gasped. It was as though the universe had been waiting behind a fogged window, and someone had finally wiped it clean. Hubble became our floating observatory of wonder. Its camera looked not only far away, but in every direction, toward the past, toward the heart of nebulae, toward the edges of clusters. It saw colour in ways no human eye ever could. And through those colours, it taught us that light is also temperature. Blue meant heat and fury, stars burning at tens of thousands of degrees, their light sharp enough to pierce dust. Red meant rest, cooler gas clouds, fading embers of long-lived suns. Gold and violet and emerald filled the spaces between, each a language of chemistry and age. When Hubble painted the Butterfly Nebula, its wings spread in twin arcs of blue fire and crimson dust. A star's last breath turned into symmetry. And then, in the same image, it caught the nursery of Pismis 24, a cluster of newborn stars shining through the pink clouds of their birthplace. In one frame, it held both endings and beginnings, death and birth, seen not as opposites but as stages of the same melody. You could almost say Hubble doesn't take photographs at all. It paints in exposure, layering light like brushstrokes, each one adding depth to the cosmic portrait. When scientists combined these layers, the result was something more than data. It was emotion. Imagine a painter working in a studio without sound, where every pigment is invisible until revealed by touch. That is what Hubble does with light. It collects the unseen, translates it into sight, and hands it back to us as something both scientific and spiritual. The butterfly's glowing arcs, the smoky blues of the Lagoon Nebula, the spiralling arms of distant galaxies, each one arrived as a gift from that silent orbit. And maybe that's why people connected to it so deeply. Hubble gave us a universe not cold and mechanical, but expressive. A place that seemed to feel, to breathe, to remember. For the first time, we saw not just stars, but stories written in colour. The dark became a gallery, each frame filled with light older than humanity itself. Even now, when we look at Hubble's images, there's something unmistakably human in them. Maybe it's because we see ourselves reflected in their imperfections. The camera that blurred, the astronauts who risked everything to fix it, the decades of patience as scientists learned to interpret what it showed. Hubble's success wasn't born from perfection. It came from persistence, from faith that if we keep looking long enough, the universe will open another layer of itself. And it did. It kept painting. There were fiery starbirths, supernova remnants, distant galaxies caught mid-collision, colours swirling like ink dropped into water. Some images took days to capture, others weeks. The telescope would lock its gaze on a patch of sky smaller than a fingernail, letting the light accumulate, photon by photon. What returned was a deep field filled with galaxies, like glowing embers scattered across ash. The first time that image appeared on screens, people wept, because in what looked like nothing, there was everything. Hubble had proven that the dark between stars was not empty at all. It was overflowing with light too faint to see until we learned the patience to wait for it. In that moment, astronomy became more than a study of stars. It became an act of tenderness, of attention, of painting patiently in the dark. And through it all, Earth kept turning beneath the telescope unaware. Oceans and cities gleamed in the sunlight below, while Hubble, moving silently above, kept gathering colour. It has seen comets tearing through the solar system, storms swirling over Jupiter's bands, Saturn's rings casting shadows like the spokes of an ancient wheel. It has watched supernovae flare in distant galaxies, their light reaching us as messages from lives already gone. But maybe its greatest gift isn't the data it gathered, but the perspective it offered. From Hubble's height, there are no borders, no noise, no lines drawn on maps, just a blue marble turning slowly through space, fragile and radiant. It reminds us that every pixel of cosmic light we see is a conversation across time, between what was and what is, between the universe and the tiny species trying to understand it. And so, Hubble continues to circle, a painter without rest, tracing the outlines of creation and memory. It has taught us that space is not just distance, it's colour, it's rhythm, it's history unfolding in silence. From here, the story will move toward the next canvases it filled, scenes of captured stars and ghostly shapes, where gravity and mystery shaped galaxies like sculptures of light. But before we go, let's pause for a breath and simply imagine it. That lone artist in orbit, still painting, still listening, still teaching us how to look. From one canvas to the next, Hubble's brush wandered deeper into the night. After it had shown us the colour of starlight and the heat of clouds, it began to reveal another kind of beauty, shapes and stories that hid in the spaces between. Where Webb would later reach further in time, Hubble lingered lovingly on the nearby wonders, uncovering patterns of balance and surprise that seemed to hint at the universe's sense of humour. Among the first of these was something faint and curious, a globular cluster known as Palomar 12. At first, astronomers thought it was an ordinary family of stars bound together by gravity and drifting through the Milky Way like a glittering raft. But its position was strange, its motion slower than it should be, as though it were a visitor rather than a native. Hubble's patient eye traced its orbit and found the truth. This cluster had been stolen. Long ago, our galaxy had passed close to a smaller companion, the Sagittarius dwarf, and quietly pulled Palomar 12 away. What we were seeing wasn't just a collection of stars, but a memory of that cosmic theft, frozen in motion. There's something poetic about that, isn't there? Stars kidnapped by gravity, carried across space, yet still glowing together after billions of years. They orbit our galaxy now as adopted children of the Milky Way. Every shimmer of light from them is a note in a song written before our planet even formed. Further out, Hubble turned its gaze toward a more familiar form, the Sombrero Galaxy. You might recognize it even if you've never heard its name. A shining disk with a dark band of dust across its middle, like the brim of a wide hat against the stars. Hubble's images of it are among the most elegant it ever made. Balanced, symmetrical, serene. The galaxy's halo glows with old golden stars. Its central bulge is bright as sunrise. If you could fly beside it, you'd see a shape that explains why galaxies spin at all. Its round disk and graceful rim are the result of billions of stars obeying one law: angular momentum, the quiet insistence that everything which turns must keep turning. Yet rather than describing it with equations, we might say it this way. The sombrero is a cosmic coin still spinning after billions of flips. Its motion is so smooth that even at its edges, where light fades to silver, you can sense the steadiness of time itself. Every particle of dust in that rim tells a story of endurance. Those grains circle the galaxy just as Earth circles the sun, bound not by walls or rails, but by the curved pull of gravity, an invisible hand tracing perfect arcs through darkness. Looking at the sombrero through Hubble's lens is like watching eternity perform a slow pirouette, but not everything in the cosmos follows such predictable grace. Some galaxies appear to resist their own rules, like dream fragments that forgot their structure halfway through. One of these is NGC 1052 DF2, a pale and ghostly spiral that seems to lack almost all of the invisible matter we once believed every galaxy needed to survive. Hubble's instruments confirmed what ground-based telescopes had suspected. The stars in DF2 move far slower than they should. It's as if someone had turned gravity down to a whisper. Without the usual cloak of unseen mass, the dark matter that makes up most of the universe, this galaxy shouldn't even hold together. And yet there it is, a soft smudge in the night, calmly existing despite the rules. Astronomers debated it fiercely at first. Was it really missing its invisible scaffolding, or had we misunderstood the angles of its motion? But Hubble kept watching, and the evidence held. Whatever DF2 truly is, it stands as a reminder that the universe enjoys exceptions. Not all galaxies are obedient. Some whisper new laws in languages we haven't learned yet. To look at Hubble's images of these worlds side by side, the stolen cluster, the perfect disk, the ghostly rebel, is to feel the same way one might feel in a museum filled with paintings of different moods. One canvas hums with structure, another with mystery, another with melancholy. Together they form a portrait of the universe as a living artist, sometimes orderly, sometimes impulsive, but always expressive. And behind every image lies the same quiet devotion. The telescope circling Earth in the darkness, the hum of instruments, the faint tap of photons striking detectors one by one. Over the years, Hubble has sent back millions of such strokes, each one a fragment of light captured across unimaginable distance. Its images are not only data, but dialogue. Between matter and curiosity, between the cold precision of physics and the warmth of human wonder. Sometimes when scientists talk about Hubble, their voices soften. They describe it as an old friend, a teacher that has never stopped showing us something new. The longer it stays aloft, the more it feels like a bridge between generations of explorers. Children who once saw their first galaxies through Hubble's eyes are now the ones guiding Webb's golden mirrors. Light passes from one instrument to another, and in that passing there's continuity, like an artist handing down a brush. The Sombrero Galaxy still glides through its slow spin. Palomar 12 still trails its path around our sky, a cluster of stolen lights. DF2 still drifts on the edge of comprehension. And Hubble, tireless, keeps adding strokes to its vast painting of the heavens. When you see its images now, you can almost feel that motion. A rhythm that's not quite human time, but still somehow familiar. It's the rhythm of everything that turns and returns. Stars orbiting galaxies, galaxies orbiting clusters, ideas orbiting understanding. Nothing in the universe stands still for long. Everything dances, even when the music is too faint for us to hear. And so, with these luminous relics and gentle mysteries before us, we follow the light onward once again. Our quiet exploration now turns toward a vast gathering of galaxies, where thousands drift together like lanterns on a cosmic sea, and beyond them, a few single stars that shine so faintly, it's a wonder we can see them at all. The trail of clues leads us gently now into a deeper darkness, where single galaxies give way to gatherings, vast, glittering congregations of light bound together by invisible threads of gravity. In the distance ahead lies the Coma Cluster, one of the grandest of these cosmic cities. It is a place where galaxies live close enough to influence one another, their halos brushing like passing ships in a slow, silent harbour. From far away it appears like a soft haze, but through Hubble's patient gaze the haze resolves into detail, 1,000 islands of stars drifting together across the deep. Each of those galaxies is a home to billions of suns. Together they form a community held in place by gravity's quiet insistence. The largest among them are elliptical, smooth and featureless, ancient by galactic standards. Between them shimmer smaller spiral forms, their arms faintly curled, their colours dulled by age. If you could look long enough, you'd see motion even here, galaxies gently swaying, orbiting one another, merging slowly in dances that take billions of years. The cluster is not frozen, it's alive with migration and memory. When Hubble captured the Coma Cluster, it wasn't just mapping structure, it was watching history unfold in miniature. Every shape, every tint of starlight told a story of how galaxies evolve, how collisions erase spirals and leave behind smooth ellipses, how gas is stripped away in the crowded environment, leaving some galaxies starved and faint. The image is busy, crowded, yet utterly serene, like a night market viewed from above, glowing quietly under a ceiling of eternity. Beyond Coma's glowing heart, Hubble's vision stretched even further, picking out solitary stars that shone with impossible faintness. Some of these were found through a trick of the universe itself, gravitational lensing, that gentle warping of space where mass bends the path of light. When a massive cluster lies between us and something much farther away, its gravity acts like a magnifying glass, brightening what would otherwise be invisible. Through this natural lens, Hubble glimpsed two extraordinary beacons, Icarus and Earendel. They are not stars within our galaxy, but single stars in galaxies billions of light years beyond. Ordinarily, such points would be far too dim to see even with the best telescopes, but the curve of space-time bent their light just enough to bring it to us, magnified for a brief cosmic moment before the alignment shifted again. Icarus was the first, its light amplified by a distant cluster until Hubble could catch it shining blue and pure. Its journey began more than 9 billion years ago, a story written in light that travelled across cosmic seasons to reach our eyes. Later came Earendel, a name meaning morning star discovered near the edge of the observable past. Its light left when the universe was still young, perhaps only a few 100 million years after the first galaxies kindled. To see it was to look back almost to the beginning of starlight itself. No equations are needed to feel the distance of that journey. Just imagine a beam of light, something that could circle our planet 7 times in 1 second, travelling non-stop for billions of years, crossing the expanding fabric of space, dodging dust and galaxies until it lands softly in a telescope's mirror and then into a human eye. That is patience made visible. That is time turned tangible. Hubble's discoveries like these change the way we think about light. It's not just illumination, it's information. Every colour shift tells us how far the light has travelled, how fast the universe has stretched since it left its source. But beyond the science, there's something simpler, a sense of intimacy. To witness a star that no longer exists, whose light only just arrived, is to realise that the universe is constantly whispering memories to us. Some of them are billions of years old. We're always listening to the past. And then there was HD1, a faint red glow seen near the very limits of Hubble's reach. It may be one of the most distant galaxies ever glimpsed, its light dating back to the cosmic dawn, when the first stars were clearing away the fog of primordial hydrogen. The glow is dim, stretched thin by expansion, but still there, a whisper from creation, proof that even the earliest chapters of the universe still echo faintly in our night. When astronomers describe such distances, they often speak of look-back time. It means that when we look far enough, we aren't seeing things as they are, but as they were. The deeper we peer into space, the further we drift into history, as though our telescopes were not instruments of glass and metal, but of memory itself. In the Coma Cluster's crowded heart, we see the middle age of galaxies. In the faint halo beyond, we see their youth. In the red glimmers near the edge, we see infancy, the moment when darkness first learned to shine. Hubble's images make this journey visible. In one field of view, we can see time itself folding backward. It's a humbling sight. Light that began its voyage before our species, before our planet, before even the sun existed, arriving just in time for us to notice. It makes you wonder how much light still wanders unseen, carrying stories no one has yet heard. And yet, for all its distance and complexity, there's comfort in this connection. The photons that began their path at the dawn of time now mingle with the light that fills our rooms. Somewhere inside each beam, there's a record of how the universe grew and cooled and became. When you look at a Hubble image, you're not simply observing space, you're participating in the act of its remembrance. As the telescope aged, its mirrors and sensors began to slow, but its vision remained clear. Every new image added another stroke to the great mural of the cosmos, another brush of light on the infinite canvas. In that long exposure of Coma and the stars beyond, Hubble reached the horizon of what its instruments could touch. It handed the torch forward to the next generation of watchers, the ones who would see farther still. And so, as we linger here among these 1,000 galaxies, we can almost sense the turning of the page. The colour begins to cool, the clusters begin to thin, and the light takes on a bluish frost. The warmth of the inner universe fades behind us as we begin our long drift outward again, away from the crowded cities of stars and into the frozen outskirts where sunlight grows faint and the memories of creation lie preserved in ice. From the crowded gatherings of galaxies, our journey now turns homeward again, back to the outskirts of our own little system, where the sun is no longer a blazing presence but a distant golden ember. Out here, light grows thin. Shadows lose their sharpness. The warmth we take for granted on Earth dwindles to almost nothing, and yet even here the story of creation continues, quietly, patiently, as it has for billions of years. If we could drift beyond Neptune, we would begin to enter a region that is neither empty nor still. It is a vast halo of ancient bodies, frozen remnants from the earliest days of the solar system. Astronomers call it the Kuiper Belt, but the name feels too simple for what it truly is. A memory ring, a vault of the solar system's past, circling in eternal cold. Each object here is like a time capsule, preserving the chemistry of the dawn, untouched since the planets first took shape. The sun, from this distance, would no longer burn your eyes. It would shine like a bright star, small but persistent, casting a pale glow across a landscape of frost and stone. The light takes hours to travel this far, and when it arrives, it touches surfaces coated in frozen water, methane and ammonia, ingredients older than the Earth itself. Nothing here grows or erodes. Time moves too slowly for that. The cold locks everything in place, preserving even the softest footprint of history. The Kuiper Belt begins when Neptune's influence wanes, spreading outward in a broad ring that encircles the sun like a faintly shimmering halo. It's not smooth, more like a field of scattered snow, dotted with thousands of small worlds. Some are the size of mountains, others as large as moons. They drift silently through the dark, each carrying the same message. We remember how it began. When scientists first predicted this region decades ago, it was only a theory, a suspicion that something must exist beyond the known planets. For centuries, telescopes saw nothing. The darkness seemed absolute. Then, in the early 1990s, the first of these objects was found, a tiny moving dot against the stars. It was the moment the edge of the solar system stopped being a mystery and became a place. Since then, we've learned that these frozen bodies share a common heritage. They were formed from the same disk of gas and dust that surrounded the young sun. While the inner planets grew dense and warm, the outer ones gathered ice and gas, and what remained beyond them became this quiet archive of beginnings. In the cold, the building blocks of worlds lingered, unaltered, molecules that once drifted freely, now locked forever into crystal. Among these icy wanderers are some that seem almost like characters in a frozen play. There's Haumea, shaped like an egg from spinning too quickly. Make, reflecting sunlight from its icy crust. And Eris, more distant still, with a frozen surface that glints like glass. Each of them orbits slowly, centuries to complete a single loop around the sun. If we could watch from above, their paths would look like the slow turning of gears in an ancient clock, steady, patient, and quiet. The temperature out here falls so low that even air would freeze solid. There is no wind, no sound, only the faint vibration of sunlight striking dust. And yet, this silence is full of meaning, because within these icy rocks lie clues to everything that came after, to how planets formed, how water arrived on Earth, how the elements that made us were first assembled. Every fragment of ice is a piece of an older puzzle, holding memories of a time before life, before oceans, before warmth. Beyond the Kuiper Belt, there's another, even more distant sphere of icy debris, a cloud so vast it may surround the entire solar system. We call it the Oort cloud, a soft shell of comets and fragments that stretches almost halfway to the nearest stars. We can't see it directly, but we feel its presence each time a comet arcs inward from the edge, flashing briefly near the sun before vanishing again into the dark. The Oort cloud is the dream beyond the dream, the final whisper of our sun's influence before interstellar space takes over. To imagine all of this is to feel both small and timeless. The Kuiper Belt and its far-flung cousins remind us that the universe doesn't discard its past. It keeps it, tucked away in places where change moves too slowly to notice. Here, the ingredients of planets and oceans wait as they have always waited, undisturbed by storms or seasons. It's a museum without walls, a gallery of ice. When spacecraft from Earth began to approach this region, they found it just as strange and beautiful as imagined. Even before the New Horizons mission made its historic journey, the data from telescopes hinted at colours and compositions that told stories of gentle collisions, slow spins, and chemical dances frozen mid-step. The belt isn't chaotic, it's tranquil. Every object orbits as if aware of the harmony of the whole. If we could stand on one of these distant surfaces and look back, we might see the sun as a pale ember surrounded by a faint mist of light. The planets all invisible to the eye, but their collective pull still felt in the slow rhythm of the orbit beneath our feet. The horizon would be absolute darkness, broken only by the scattered glow of distant stars. Each one of those stars, too, has its own ring of ice, its own frozen relic circling quietly. We're not alone in keeping such memories, and so, this is where we find ourselves now, at the edge of the sun's warmth, listening to the oldest silence we've ever known. Beyond Neptune, beyond the last of the familiar planets, lies a halo of frost that guards the beginning of everything. It is not a desolate place. It is a library of what once was and what might be again. From here, our quiet journey will move inward just a little, toward one small world that once marked the end of our maps, Pluto, and the messenger that visited it. But before reaching that world, we'll pause at something even smaller and more mysterious. A distant object shaped like two hands meeting in the dark. A frozen sculpture of gentleness named Arakoth. If we follow the faint sunlight a little farther, we reach a place where even time itself seems to hesitate. Here floats a tiny world that looks almost like a toy, sculpted by a child's gentle hands. A world made of two spheres pressed softly together, one larger, one smaller. Connected, not by violence but by grace. The scientists who first saw it called it Arakoth, a name that means sky. But most people remember it by its first description, the snowman at the edge of the solar system. Arakoth drifts in a part of the Kuiper Belt so distant that sunlight arrives weak as moonlight through fog. It's a place where temperatures fall hundreds of degrees below freezing, where space dust glides unhurriedly through a velvet dark. When the New Horizons spacecraft finally reached it, after crossing billions of miles, it found something astonishing, the first truly pristine relic from the dawn of the planets. To understand why this little snowman matters, we have to imagine what the early solar system was like. Long before there were worlds or oceans, the sun was surrounded by a disk of gas and dust. Within that disk, countless grains began to stick together, first by static, then by gravity, forming clumps that grew into boulders and then into proto-worlds. But there was a puzzle. The old models said these collisions must have been violent, breaking objects apart as often as they joined them. And yet everything we see around us, the planets, the moons, suggests that somewhere, somehow, these early pieces managed to meet gently enough to build something lasting. Arakoth became the answer to that question. When New Horizons flew past in 2019, its cameras revealed a shape no one had expected. Two lobes fused together so delicately that even their contact point was smooth. No cracks, no shattered debris, no signs of impact. Just two bodies that had drifted together slowly, like dancers meeting in slow motion. The evidence was clear. Worlds can form not through violence, but through calm. The two lobes tell a story of cosmic patience. They likely formed side by side in the same cloud of dust, orbiting each other gently for millions of years before finally touching. Their union was less a collision and more a settling, like two soap bubbles merging into one. In that moment, a miniature world was born, shaped not by chaos but by stillness. When the images arrived on Earth, they felt strangely familiar. People compared them to snowmen, to hourglasses, to sleeping figures. There was something comforting in their symmetry, something almost human about the way they leaned together. The science was profound, but so was the feeling, a sense that the universe, in its earliest days, was capable of tenderness. The surface of Arakoth is smooth and reddish, coloured by organic molecules altered by sunlight over billions of years. Its texture is soft in the images, no sharp mountains, no deep craters, just gentle undulations like dunes frozen in time. Some parts gleam brighter, reflecting faint sunlight, while others absorb it, turning rust-coloured in the shadows. It's a landscape that feels untouched, as though it has been sleeping since the first dawn. For the team at NASA, the flyby was both triumph and farewell. The spacecraft that captured these images, New Horizons, had already given us our first close look at Pluto a few years earlier. To reach Arakoth, it had to travel farther still, navigating through darkness guided by calculations and trust. When the data finally came back, a trickle of signals sent across billions of miles, it confirmed not just a theory, but a truth about how worlds are made, through quiet gathering, not constant collision. There's something deeply moving in that revelation. We often imagine creation as an explosion, a sudden burst of energy and force. But Arakoth reminds us that sometimes the universe builds through patience, through the smallest acts of attraction. Dust becomes stone, stone becomes planetesimal, and somewhere along the way, two pieces meet and never let go. If you could float beside it, you might not feel the pull of gravity at all. You drift beside this twin-lobed world as though hovering over an ancient sculpture. The sunlight would be so faint that it would take hours to brighten the horizon. The stars would crowd the sky in unblinking clarity. And if you looked down, you'd see shadows that haven't moved in millions of years, stretching across plains of frozen methane and water ice. In the silence around it, New Horizons was the only moving thing, a mechanical snowflake gliding through infinity. Its instruments measured temperature, colour, texture, and even the faint gases that might hover above the surface. Each bit of data was a heartbeat from a world that never knew warmth, never knew day or night, only the eternal twilight of distance. And yet, in that stillness, there is story. The story of how every planet, every moon, perhaps even Earth itself began with moments like this, with dust meeting dust, with fragments, drifting closer until they found balance. When we look at Arakoth, we are looking at our own origin told in miniature. Its frozen curves are the echo of a cosmic embrace that eventually gave birth to everything we know. The scientists who studied it described its shape in gentle words. It's peaceful, one said. It's simple, but it's telling us something enormous. Another called it a snapshot of the first chapter of the solar system's story. Even those trained to speak in data and measurement couldn't help but use the language of feeling, because that's what Arakoth awakens in us, the realization that we come from something both immense and intimate. If you could listen to the silence around it, it might sound like snow falling in slow motion, or like the hush between two breaths. The spacecraft continued past, growing smaller against the background stars, its signal weakening but steady. Behind it, the snowman world turned slowly, unbothered, serene. It will remain like that long after we're gone, two halves joined forever, orbiting a sun too far away to warm them, but near enough to keep them company. From here, the path leads inward again, to a larger, more familiar wanderer, the world we once called the ninth planet. There, ice gives way to faint colour, and cold becomes something slightly more welcoming. Pluto waits in the dim light ahead. its heart-shaped plane gleaming like a frozen smile across the dark. The trail of light leads us inward again, through a frost-bitten corridor where sunlight returns, faint but steady, washing the dark in a pale amber glow. Ahead drifts a small, distant world that once marked the outer boundary of every schoolroom map, a place that for decades was known as the 9th planet, then quietly reclassified, though never forgotten. Its name is Pluto, and despite its demotion, it remains one of the most beloved wanderers in the solar system. For most of human history, Pluto was nothing more than a moving point of light, so far away that even our largest telescopes could not reveal its shape. It was the mystery at the edge of our reach, tiny, cold, and endlessly patient. Then, after nearly a decade of travel, a small spacecraft called New Horizons arrived, moving faster than any probe before it. In July of 2015, for a brief few hours, the unknown became known. The images it sent back changed everything. Pluto was not a dull grey rock, but a world of colour and complexity, a landscape painted in soft reds, whites, and hints of gold. Across its surface, plains of nitrogen ice stretched between rugged mountains of water ice so cold they might as well be stone. And in the centre of it all, gleaming like a symbol carved into the face of time, was a vast heart-shaped plain, a region now known as Sputnik Planitia. At first glance, it looks like a patch of smooth frozen glass, but that heart isn't static, it's alive in a slow geological way. The plain is made of solid nitrogen that behaves almost like wax under extreme cold, flowing over centuries, rising and falling as Pluto's interior breathes heat from within. You could think of it as a frozen ocean that moves so slowly it appears eternal. The patterns on its surface form great polygonal cells, each a field of ice 100 kilometers wide, all drifting and churning like the surface of a living planet. Some scientists believe the plain was born from a colossal impact long ago, a glancing collision that left a basin which filled with nitrogen frost. The idea feels almost mythic, a wound that became a heart. The impact would have tilted Pluto's axis, shaping the patterns of sunlight it receives, and even guiding the migration of its ices over eons. What was once destruction became identity. But the heart is more than beauty. It holds secrets about heat and motion deep within the dwarf planet. Beneath that shining surface there may lie an ocean, hidden, buried, and ancient. Though the cold here is unimaginable, the decay of radioactive elements inside Pluto's core releases enough warmth to keep part of it liquid, at least in theory. If true, it means Pluto, so far from the Sun, might still be whispering with the sound of flowing water far below its icy crust. As New Horizons passed, it looked back toward the edge of the world and saw sunlight scattering through a haze of thin atmosphere. The glow was pale blue, unexpected and breathtaking. It revealed that Pluto has skies, faint though they are, layered with delicate sheets of haze reaching hundreds of kilometers upward. They form when sunlight breaks apart molecules of methane and nitrogen, creating tiny particles that drift downward, painting the surface in soft pink tones. In that moment, Pluto stopped feeling like a statistic and became a world, a fragile, intricate one, alive with quiet processes and endless patience. Circling beside it is Charon, Pluto's largest moon, and in a way its twin. The two worlds orbit one another like dancers locked in perpetual embrace, each always showing the same face to the other. From Charon's surface, Pluto never rises or sets. It just hangs in the same spot in the sky, a golden globe surrounded by the slow drift of stars. The two are bound by a balance so perfect that their centre of gravity lies in the space between them. It's a partnership, not domination, a cosmic equality. Charon too carries stories written in ice. Its surface is crisscrossed by vast canyons and scars that hint at a violent youth. One of the most striking features is a massive belt of cliffs stretching halfway around the moon. a scar that suggests Charon once had an internal ocean that froze long ago. As the water turned solid, it expanded, cracking the crust open like the skin of a drying riverbed. Even in its stillness, you can read motion in its bones. Its northern hemisphere glows with a reddish hue, stained by material escaping from Pluto's atmosphere and falling back like snow. The colours between the two worlds mingle, as if they were exchanging pigments on a shared palette. Where Pluto's surface is bright and youthful, Charon's is dark and ancient, yet both hold each other in gravitational harmony, a pair of companions wandering together through the long, cold night. For the engineers and scientists watching from Earth, this meeting between worlds was both a triumph and a goodbye. New Horizons raced past Pluto at nearly 14 kilometers per second, so fast it had only a few hours to capture decades' worth of curiosity. After the encounter, it continued outward, heading deeper into the Kuiper Belt, where it would later find Arakoth, the snowman world we just visited. But even as it moved on, it kept listening, sending back faint signals from a distance so immense that each radio whisper took more than 5 hours to reach us. When you look at Pluto's heart, it's hard not to see a kind of poetry in its shape, a message carved by time, fragile, resilient, and quietly luminous. In that distant landscape, love is measured not in warmth or comfort, but in endurance, the way ice endures, the way orbits endure, the way curiosity endures. For all the coldness of its environment, Pluto feels oddly welcoming, like a memory you didn't know you had. The sunlight here is pale, yet enough to paint long shadows across mountains of frozen water. The horizon curves tightly beneath your feet. The stars never twinkle, only shimmer steadily against the black. Standing there, if one could, you'd see the sun as a bright dot low in the sky, almost like any other star, and you might realise that home has never looked so far, and yet so close in meaning. From this lonely heart and its silent moon, the journey stretches onward again. The New Horizons probe continues its slow flight into the deeper dark, leaving behind faint trails of data like breadcrumbs of light. Ahead lies a frontier even quieter, the thin edge where the sun's breath gives way to the wider ocean of interstellar space. There, the Voyagers wait, their old instruments still whispering across the void. But before we reach them, let's carry this image of Pluto with us, a tiny world with a heart, beating softly in the cold, reminding us that even at the edge of everything, warmth can still exist. Our quiet path now turns toward two small travellers, machines so old that they were built when humanity still listened to music on magnetic tape and stored its hopes on slivers of metal the size of a keychain. They were made before home computers were common, before anyone had ever seen Earth from space in colour television, and yet even now they are still moving, still whispering across the dark. Their names are Voyager 1 and Voyager 2, and they are older than most of the memories we have of exploration itself. They were born in the 1970s, in rooms humming with typewriters and soldering irons, their circuits, hand-wired by engineers who could not yet imagine the internet but who could imagine eternity. The Voyagers were meant to last 5 years, just long enough to visit Jupiter and Saturn, take some photographs, and then fade quietly into the background. Instead, they have outlived generations of scientists, 2 centuries worth of technology, and the very language in which they were designed, built for 5 years, alive for 50. At the heart of each Voyager lies a tiny furnace, a device known as a radioisotope power generator. But rather than using that cold term, think of it this way. Each carries a small heart of slow fire, a handful of plutonium pellets, sealed inside protective shells, release heat as they decay, and that heat is turned into electricity. It's not much, barely enough to power a household light bulb, but it has kept these travellers alive through half a century of night. Those quiet hearts still glow, warming their instruments against the cold that would freeze metal solid. From the moment of launch, they were flung into a cosmic pinball machine, a careful alignment of the outer planets that occurs only once every 176 years. Using the gravity of one world to fling themselves toward the next, they leapt from Jupiter to Saturn to Uranus and Neptune, stealing speed with each swing. The technique is called a gravity assist, but the phrase hardly captures the grace of it. Picture two dancers meeting in motion, one spinning, one passing by, the second catching a bit of the first's momentum and using it to sail onward. That's how the Voyagers travelled, drifting from world to world on tides of gravity and geometry. Their onboard computers were tiny by our standards. Each carried less memory than a digital watch does today, stored on magnetic tape that clicked softly as it turned. To send instructions, engineers on Earth had to think days ahead. Every movement of the camera, every turn of the antenna had to be programmed and transmitted across billions of kilometres of emptiness. And when the signal finally returned, faint and delayed, it came in the form of numbers, strings of radio tones that had to be decoded into images. Yet from those numbers, the Voyagers sent back visions that changed the way we see our solar system. They revealed storms bigger than Earth itself, moons with oceans hidden under ice, and colours we had never imagined existing so far from the sun. The spacecraft became mirrors of human curiosity, reflecting our need to know what lies just beyond the next horizon. Each one carries a golden disc bolted to its side, a message for anyone or anything that might one day find them. But that story belongs to another part of our journey. For now, imagine the spacecraft themselves, spinning slowly, their thin antennas stretched out like the stems of metallic flowers, always turned toward a fading point of light that they still call home. It is strange to think that these two silent machines have travelled farther than any living creature ever will, and yet they are entirely made by human hands. Every bolt, every circuit, every engraved letter was touched by someone who once walked beneath a blue sky, someone who may be gone now but whose work still crosses the interstellar dark. The Voyagers are not just machines, they are memories that learned how to move. Their design was simple, almost humble, a high-gain antenna shaped like a dinner plate, a long boom to hold their magnetometers, cameras that blinked like eyes, and a tape recorder to store data when Earth was too far away to listen in real time. They carry instruments that measure magnetic fields, cosmic rays, and the whisper of plasma flowing from the sun. When you read their blueprints, it feels like reading a love letter written in numbers, a promise that something built with care can survive the chill of eternity. The spacecraft talk to Earth through the Deep Space Network, giant radio dishes scattered across the world waiting to catch their faint signals. Each time they speak, the message travels for hours before it arrives, as though time itself stretches between question and reply. The signal is weaker than the static of a snowstorm on an old television, but within that static lies information, the heartbeat of an object moving more than 20 billion kilometres away. In their aging circuits, the Voyagers still keep rhythm. Occasionally engineers must turn off another heater, another camera, another instrument to save the last traces of power. Each switch is a farewell, each decision a quiet acknowledgement that nothing can run forever. Yet even as their energy fades, they keep transmitting. There's an almost human stubbornness in that persistence, a refusal to fall silent until there is truly no more to say. The people who built them often speak of them as living beings. They refer to them as she, not it, because somehow it feels wrong to call a traveller it. When Voyager 2 crossed the orbit of Neptune in 1989, the last planet on its itinerary, one of the engineers whispered, "She's free now." And it was true. From that moment onward, both Voyagers were no longer bound by destinations. They were simply moving outward, beyond maps, beyond sunlight, beyond even our imagination of what lies between the stars. As they drifted away, their instruments kept listening to the faint breath of the solar wind, the stream of charged particles that flows from our sun. They recorded its thinning, its fading hum, the way the warmth of the sun's influence ebbs with distance. Soon, they would reach the boundary where that wind meets the interstellar medium, the edge of the bubble that protects our solar family from the wider galaxy. But that crossing, the moment when our machines touch the true ocean of the stars, belongs to another chapter. For now, we leave them as they were in their youth, gleaming, hopeful, alive with the warmth of their slow hearts. They were built in an age of optimism by people who believed that curiosity itself was a kind of survival. And perhaps it is. Because even now, when most of those hands and voices have gone quiet, the Voyagers still speak. Their words are made of data and distance, but what they really say is simple. We are still here. We are still listening. The trail of light carries us now into the great symphony of the outer planets, where the Voyagers perform their finest dance. The path they took, Jupiter, Saturn, Uranus and Neptune, was not a straight line but a slow, spiralling melody of gravity and time. The planets themselves were the notes, and the spacecraft became the instruments playing them, recording the music of the solar system as no one ever had before. Jupiter was the opening chord, deep, thunderous, magnificent. As Voyager approached, the giant filled its cameras with bands of swirling clouds, each moving in its own rhythm. These weren't just patterns of colour, they were storms larger than Earth, turning endlessly in the planet's dense atmosphere. The great red spot, that ancient hurricane, spun like a living eye that had watched for centuries. Through the thin hiss of radio waves, scientists could even sense its lightning, a spark of energy bright enough to light a world. Voyager 1 and 2 captured it all. The delicate bands of cream, ochre and rust, the glimmer of sunlight reflecting off the clouds, and beyond that, a surprise. Around Jupiter, faint rings appeared, thin arcs of dust that no one had known were there. They were subtle, almost invisible, as though the planet had been hiding jewellery beneath its storms. And then came the moons. Each one revealed a different personality, a different chapter in the book of creation. Ganymede, bigger than Mercury, shone with grooved ice plains. Callisto looked like a scarred relic, ancient and cratered, as if it had endured every collision the early solar system could throw. Europa gleamed pale and smooth, crossed with thin lines that hinted at something beneath, an ocean, perhaps, buried under ice. Voyager's instruments could not see through the crust, but they felt the magnetic pull that suggested salt water deep below. And then there was Io. No one expected what they saw there. As the spacecraft passed, its cameras caught plumes of material rising hundreds of kilometers high, volcanoes erupting into space. Io was alive with fire. It became the first place beyond Earth where we discovered active volcanism, its surface reshaping itself in real time. The discovery shocked and delighted scientists. In a universe of ice and silence, here was a moon that breathed heat. Jupiter's gravity then flung Voyager outward, sending it towards Saturn, the second movement of the symphony, lighter but no less profound. When the spacecraft arrived, its cameras filled with the image that would come to define beauty in astronomy. The rings. Not solid bands, as people once imagined, but countless particles of ice and dust, each reflecting sunlight like mirrors scattered through a frozen stream. Seen through Voyager's eyes, they shimmered in shades of pearl and silver. Some scientists said they looked like frozen music, waves of resonance carved into matter by gravity's rhythm. Voyager also met Saturn's family of moons. Titan, the largest, was wrapped in a thick orange haze, a sky so dense that its surface was hidden entirely. We would later learn that beneath that haze lie rivers and seas of methane, an alien version of home. Enceladus, a smaller moon, surprised everyone. As the probe passed, it detected plumes of vapour spraying from cracks in its surface, like breath escaping from a sleeping creature. Inside that icy shell was warmth, and perhaps an ocean, echoing Europa's mystery. By the time Voyager 2 continued onward, the world had changed. Scientists spoke of moons not as cold stones, but as worlds in miniature, each one unique, each one alive in its own way. The mission was supposed to end after Saturn, but there was just enough fuel left to continue. The spacecraft adjusted its path and set course for Uranus, the first time any human creation had ever visited that distant tilted planet. Uranus turned out to be stranger than anyone expected. Its blue-green colour came from methane in its atmosphere, but its most peculiar feature was its orientation. The planet spins on its side, as if it had once been struck and left forever leaning, its poles pointing almost where its equator should be. Seasons there last decades, each half of the planet spending years in continuous daylight followed by years of night. The Voyager images showed faint rings and a subtle shifting glow, a quiet, sideways world that felt almost dreamlike. Around it, the spacecraft found moons with personalities as odd as the planet itself. Miranda, the smallest and perhaps most poetic, looked like a jigsaw puzzle that had been taken apart and clumsily reassembled. Its cliffs and ridges told of ancient upheavals, of a moon broken and reborn. Some scientists said it looked as if the universe had tried sculpting and, dissatisfied, had started over. From Uranus, Voyager made one final leap, flinging itself toward the last of the giants, Neptune, the farthest planet the mission would ever see. The journey took years, and when it finally arrived in 1989, the world greeted it with colour. Neptune's deep sapphire hue glowed against the black, its winds among the fastest in the solar system. Great dark storms roamed across its face, vast enough to swallow Earth whole. And then came Triton, Neptune's largest moon, a cold, pinkish world that orbits backward against the planet's rotation. Its surface was marked by strange, smooth plains and icy geysers, jets of nitrogen gas erupting into space, freezing mid-flight before falling back as snow. Triton may once have been a wanderer captured by Neptune's pull, another small act of cosmic adoption. Voyager watched its geysers rise and vanish, each plume a whisper of motion in the eternal cold. By the time the spacecraft turned its cameras for one last look, it had seen more of the solar system than any explorer before or since. From Jupiter's roaring storms to Neptune's icy winds, it had travelled through 4 worlds and dozens of moons, transforming dots of light into places with faces and stories. The data it sent home filled shelves of books and generations of dreams. When the final images came through, tiny, faint, distorted by distance, they still carried wonder. Against the darkness, Neptune shone as a small blue coin, surrounded by its rings, and beyond it, the stars stretched on forever. Voyager's journey through the giants was complete, but its voyage through the universe was only beginning. And so, we leave it drifting at the edge of sunlight, where the warmth of the sun fades into silver and the solar wind begins to thin. Ahead lies a boundary, an invisible frontier where the breath of the sun meets the quiet of interstellar space. There, the Voyagers would become something new, the first messengers to leave home and keep going. From Neptune's blue horizon, the Voyagers continued their silent drift outward. Behind them, the sun had shrunk to a bright star, still fierce, but no longer dominant. The warmth that once filled their instruments now reached them as a faint touch. The planets faded into the distance one by one until there was nothing left but darkness, starlight, and the thin breath of the sun's wind stretching into space. This was the edge of the heliosphere, the invisible bubble carved into the galaxy by our star's steady outflow of particles. It's easy to imagine the sun as a lamp, glowing only with light, but it also exhales. It sends out a constant stream of charged particles, an invisible wind that fills a vast region around it. Within this bubble, everything is warmed and shielded by its presence. Beyond it lies the true interstellar ocean, a sea of atoms and radiation from other stars. The place where one ends and the other begins is not sharp but gradual, a threshold that breathes. The Voyagers had been heading toward that threshold for decades. Their instruments recorded the thinning of the solar wind, the softening hum of its magnetic rhythm. Then, one day, the data began to change. The numbers, when translated into sound, made a different kind of music, a low, vibrating tone that rose and fell like the voice of a faraway tide. The sun's wind was colliding with the pressure of the galaxy beyond, forming a boundary of shimmering plasma. Scientists have poetic names for these layers. The first is the termination shock, where the solar wind slows abruptly, like waves meeting the open sea. Beyond it lies the Helios Heath, a turbulent region where those winds swirl and mingle with the galactic current. Farther still is the Heliopause, the true edge of our sun's influence, the outer wall of our solar home. The Voyagers, in their slow and patient journey, pass through each of these stages, recording the sounds of a cosmic shoreline. Imagine standing at the edge of an invisible ocean, feeling not water, but charged particles flowing around you. The sound that Voyager 1 detected there wasn't sound in the way we hear it, but vibrations in plasma, the background hum of interstellar space itself. When translated into frequencies our ears can recognize, it became a soft, eerie tone, rising gently like wind across glass. It was the first time we had ever heard the music of the space between stars. Voyager 1 was the first to cross in 2012. For years, scientists had debated exactly where that edge would lie. When the data finally showed that the solar wind had dropped away and cosmic rays from the wider galaxy were streaming in freely, they knew the little spacecraft had entered a new realm. The first human-made object had left the sun's protective bubble and stepped into the galaxy's open air. Voyager 2 followed 6 years later in 2018, crossing at a slightly different point, as though taking a parallel path through the veil. Each crossing told us something subtle and profound. The edge of our solar system is not a wall. It's alive, rippling, expanding and contracting with the rhythm of the sun's magnetic cycle. It breathes, just as we do, with a pulse measured not in seconds, but in years. The Voyagers sent back their data slowly, in whispers so faint that it took hours to arrive. Engineers on Earth gathered around computer screens, watching the numbers come through, a stream of digits from a machine billions of kilometers away. Those digits became sound, became graphs, became realization. Humanity, for the first time, had reached beyond the warmth of its own star. But what lies beyond that boundary is not emptiness. The interstellar medium is full of traces, atoms and dust, magnetic fields stretched thin, the ashes of ancient stars drifting like pollen. Voyager's instruments could feel their faint pressure, mapping the texture of the galaxy's breath. Later, new missions like IBEX, the Interstellar Boundary Explorer, would piece together those whispers into a global image, showing a strange ribbon of particles curling around our bubble. It looked like an aurora drawn on the skin of space, glowing softly where solar wind met galactic tide. Future missions like IMAP will soon continue that work, listening for how our sun's exhalation changes as it moves through the Milky Way's unseen weather. When you picture it, the scene is simple, yet profound. Two small travellers, each no larger than a family car, floating in an ocean so vast that even light takes years to cross it. Their antennas still point home, though home is now just a pale dot in a sea of stars. They send their signals one by one, tiny ripples in the radio spectrum, messages written in time delay. Earth listens, patient, catching each breath before it fades. If the Voyagers could feel, they might sense the subtle difference of where they are now. The silence deeper, the light colder, the stars sharper against the dark. They have become part of the interstellar wind themselves, drifting where no sunlight shines, where the sun's magnetic whisper fades into the galaxy's murmur. And yet, in their tiny machines, the memory of warmth remains, a trace of the world that launched them. There's something poetic about the way the boundary was found not by sight, but by sound. The universe, it turns out, is not mute. It hums softly everywhere. Plasma waves, cosmic rays, the echoes of creation. The Voyagers became our first microphones, recording the breath of space itself. When scientists play those sounds in lectures, the audience always falls silent. The hum rises and falls, simple, ghostly, strangely soothing. It's not a sound meant to comfort, yet it does. Perhaps because we recognize something familiar in it. The rhythm of breathing, the cadence of the ocean, the background pulse of life. Even in the interstellar dark, there is continuity. And so, the Voyagers crossed the final border of our sun's reach. Behind them stretched everything we've ever known. Ahead of them, everything we've yet to understand. Their mission continues even now, their tiny hearts of fire still glowing faintly. Beyond the bubble, there is only the tide of stars. Out there, beyond sunlight and warmth, two travellers continue their journey. They drift through a darkness so deep that even starlight hesitates before touching them. Yet, from billions of kilometres away, their faint voices still reach us. A soft pulse of radio waves crossing the void. Each message takes more than half a day to arrive, carrying no image, no sound, just meaning. Machine to human, silence to wonder. Voyager. 1 and Voyager 2 are no longer explorers in the usual sense. They are storytellers now, aging messengers that whisper of what they've seen. Their energy slowly wanes. The tiny hearts of slow fire that kept them alive for almost 50 years are growing weaker. One by one, the engineers have let their instruments rest. The cameras were first to go dark, then the magnetometers, then the heaters, each shut down a small farewell. And yet, they continue, defying the odds, like old souls who simply refuse to stop breathing. In 2022, one of them faltered. Its data came back tangled, as if it had forgotten its own language. Lines of code turned to static. For months, engineers listened and guessed, sending careful commands across the gulf. Then, quietly, the spacecraft answered. The numbers aligned again. She remembered the right words, one engineer murmured, smiling at the thought. Moments like that blur the line between machine and memory. The Voyagers are, in their own way, companions, silent friends wandering ahead of us into forever. When they go quiet and return, it feels like hearing from someone you'd feared lost. To keep speaking to them across billions of kilometers demands not technology, but tenderness. Their power will fade completely one day. Their voices will fall silent, not as an ending, but as a transformation. They will drift on, beyond the sun's reach, past the outer arms of the Milky Way, and perhaps one day into another star's light. They will not die. They will simply join the quiet, carrying our story with them. That story is etched in gold. Before leaving, humanity gave each probe a gift, a record, plated in gold and sealed for time itself. The golden record carries the sound of who we are. It holds greetings in more than 50 languages, the laughter of a baby, the song of a whale, the sound of rain, of footsteps, of a kiss. There's music, Bach and Mozart, Navajo chants, Senegalese drums, a Peruvian wedding song, and Chuck Berry's Johnny Be Good, because joy too deserved to travel among the stars. On the cover are simple drawings, how to play it, how to read it, where to find us. Lines mark the position of Earth among the pulsars, our cosmic address. The message was never a cry for discovery, only a greeting. We are here. We existed. We wondered. Carl Sagan, who helped design it, called it a bottle cast into the cosmic ocean. Years later, Sagan asked the spacecraft to turn its camera back toward home. One last look. From nearly 6 billion kilometers away, Earth appeared as a single pale dot suspended in sunlight. He wrote, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, every human being who ever lived their life, every joy and sorrow lived there, on a mote of dust suspended in a sunbeam." That pale blue dot became our portrait from the edge of the known. The image was almost empty, but that emptiness was the point. It reminded us how delicate we are, how everything we've ever built or believed fits into a single pixel of light. The Voyagers had not only shown us other worlds, they had shown us ourselves. The golden records still travel with them, their surfaces gleaming faintly in the dark. They spin slowly, waiting for eyes or minds that may never come. But being found isn't the purpose. The record's value lies in the act of sending it. Across distances where even light grows tired, 2 small messengers carry the sound of Earth's first hello. Inside those grooves are images and sounds that describe life in all its quiet beauty. Forests, oceans, a mother and child, mathematical diagrams, DNA spirals. The heartbeat that begins the record still synchronizes easily with your own. When played, it feels strangely familiar. The laughter real, the thunder soft, the music human. It's not a record of achievement, but of affection. For those who built the Voyagers, the golden record was an act of faith. Faith that curiosity might become connection, that even a silent universe might listen. And maybe that's what we've always wanted. Not to be answered, but to be heard. Today the signals that reach us are so faint, they thread through the cosmos like candlelight lost in a storm. Yet Earth still listens. Not for discoveries, but for continuity. For proof that something we made is still out there. Still moving. Still remembering home. Someday soon, their power will run out. The Voyagers will drift quietly between the stars, carrying our voices long after we've forgotten how to send them. 1 billion years from now, the gold may still gleam, spinning in darkness. Perhaps no one will find it. Perhaps that's fine. It was never about being found. It was about the gesture. We built them not to conquer space, but to be remembered by it. To say simply, on a small blue world in one corner of the galaxy, there once lived beings who loved, who dreamed, who sent music into the stars. Carl Sagan called the record our lullaby to the universe, and that's what it is, a soft song of existence. When we play those sounds today, the heartbeat, the laughter, the rain, we remember that we belong to something vast, and yet somehow it belongs to us too. Even as the Voyagers fade, their legacy glows like embers in the dark. They remind us that exploration isn't about reaching an end, but about carrying light forward, even when the light grows dim. Somewhere beyond the heliosphere, 2 tiny sparks of human hope glide through eternity, whispering into the void. We were here, we cared, we sang. From the faint song of the Voyagers, we now drift further still, past the reach of sunlight, past even the boundary of the sun's breath. Out here, there is no sound except the whisper of radiation, no warmth except the faint memory of stars. And yet, something moves, something vast, invisible and persistent. It tugs, not on us, but on galaxies themselves. Astronomers call it, with gentle hesitation, the dark flow, a name that feels more like a poem than a measurement. It began with a puzzle. Clusters of galaxies, separated by billions of light years, seem to be drifting in the same direction, as if pulled by an unseen tide flowing beyond the edges of the observable universe. No one could see what caused it, but the numbers whispered that it was there. To understand why this is strange, we must imagine the limits of our vision. Every telescope, even the most powerful, is bound by time as much as distance. The farther we look, the older the light we see. And beyond a certain point, about 46 billion light years in every direction, there is a horizon we cannot cross. Not because of walls or matter, but because light itself has not had time to reach us yet. That invisible border is called the cosmic horizon. It's the limit of what the universe has revealed so far, the edge of the visible ocean. Beyond it lies everything that still waits to be seen, still hidden behind time's curtain. But even within that horizon, the cosmos should look the same in every direction, balanced, calm, uniform on large scales. The universe, according to our best models, expands evenly. Yet, in the early 2000s, scientists studying the faint glow of the Big Bang, the cosmic microwave background, found something curious. They noticed that massive clusters of galaxies were moving slightly faster than expected, as though drawn toward a point beyond the horizon. It was as if space itself had developed a current. The cosmic microwave background, or CMB, is the oldest light we can see, the first radiance that filled the universe after it cooled enough for atoms to form. It's not visible light, but a soft microwave glow, the faint after-image of creation. You can think of it as the static you hear when a radio isn't tuned properly, or the faint hiss of an old television between channels. That static is ancient, almost 14 billion years old, and within its tiny variations lie the fingerprints of everything that followed. Galaxies, stars, planets, us. Scientists use the way galaxy clusters distort this ancient light to measure their motion, much like watching ripples move across a pond to infer the current beneath. The method is technical, but the image is simple. The galaxies act like boats drifting on a cosmic sea, and the CMB is the reflection of dawn upon the water. By measuring the small shifts in that reflection, astronomers could tell which way the boats were moving, and the surprising part, they all seemed to be drifting toward the same distant region of the sky, somewhere near the constellations of Centaurus and Hydra, as if something enormous were pulling from beyond the horizon. That was the birth of the dark flow mystery. What could tug on galaxy clusters from outside the observable universe? What kind of mass or motion could reach across time itself? For a while, the simplest idea was gravity, something unimaginably large exerting its pull. Perhaps, some said, it was a remnant from before the Big Bang, a neighbouring universe pressing against ours like a bubble against another bubble. Others wondered if the pattern was only an illusion, a trick of incomplete data or cosmic coincidence. But for many, the idea carried a strange allure. It suggested that what we can see, the galaxies, the nebulae, the shimmering arcs of light, might be just one small patch in a far vaster tapestry, each section flowing toward or away from others in an infinite cosmic sea. To speak of such things is to stand at the border between science and imagination. We don't yet know if the dark flow is real. The evidence is subtle, the data delicate, and later surveys with different instruments like the Planck satellite found less certainty. But even the doubt has its beauty. It reminds us that mystery still breathes inside our equations, that there are questions vast enough to humble every certainty we've ever held. The idea of a current in the cosmic sea brings an odd sense of comfort. On Earth, we have tides, winds, and weather, forces we can feel but not always see. Perhaps the universe has its own version of weather, its own great winds flowing across the fabric of space-time. Not storms of air or water, but of motion and light, galaxies moving like leaves carried by the faintest of cosmic breezes. If the dark flow exists, it tells us that the universe is not entirely uniform, that beyond the limits of what we can observe, something vast may be shaping our motion, something from before our beginning, or from another region of existence altogether. It would mean that the cosmic horizon is not an end, but merely a veil, hiding structures so immense that even light cannot yet tell us their stories. And yet, whether the effect is real or illusion, the wonder it evokes is the same. It makes us look outward with renewed curiosity, reminding us that our measurements are always partial, our perspective always local. We are travellers still standing at the shore of the infinite ocean, watching the waves and guessing at the depths beneath. In the soft static of the universe's first light, we can almost imagine hearing it, the faint ancient hum of the cosmos, rippling through time. The galaxies drift, and we drift with them, carried by currents we can barely perceive. Perhaps that's what all discovery feels like, the recognition that something unseen moves beneath everything we know. And so, from the faint radio whispers of Voyager to the silent tug of distant galaxies, the theme continues. There is always another horizon, another question just beyond reach. The dark flow may be a myth of measurement, or it may be the first hint of something beyond everything we've yet understood. But in either case, it calls to us, not with urgency, but with invitation. As we linger at the edge of that cosmic current, the universe feels less like a machine and more like a living sea. And though we cannot yet see what lies beyond, we can feel it. The edge that pulls is not only out there, it is also within us, that same urge to move, to seek, to be carried a little further into the dark. If we follow the thread of that unseen current a little further, it begins to lead us backward, not just through space, but through time. Every question about what moves the galaxies eventually drifts toward the same quiet place, the beginning, the moment when everything began to expand, to cool, to create. And perhaps, within that first heartbeat of existence, we can find the faint memory of whatever now tugs from beyond the horizon. In the late 20th century, a young physicist named Alan Guth tried to solve a puzzle about the early universe. The cosmos we see today is astonishingly even. No matter which direction you look, the temperature of the ancient light left over from the Big Bang differs by only the smallest fraction of a degree. Yet, if the universe had expanded slowly and steadily from the beginning, distant regions could never have been in contact to even out those differences. They would have been too far apart for light or heat or information to pass between them. It was as though someone had baked a cake and somehow managed to make every part of it the same temperature before the oven was even turned on. Guth's idea was bold and strange and beautiful. He suggested that, for a tiny instant after the Big Bang, far shorter than a blink, shorter than the flutter of a photon crossing an atom, the universe expanded faster than thought itself. Not gradually, but explosively, swelling from subatomic size to cosmic scale in what we now call cosmic inflation. You can think of it like breath fogging on glass. One moment a mist, the next, the whole pane filled. In less than the blink of creation's eye, the universe grew by a factor so vast it can barely be imagined. Space itself stretched, carrying every particle outward faster than light could travel, not through violation, but through expansion. Because space isn't bound by the same limits as motion, it can unfold freely, like fabric pulled at its edges. In that unimaginable moment, any irregularities that existed before, tiny fluctuations in the density of energy, were stretched out as well. They became the seeds of everything that would follow: galaxies, clusters, the cosmic web itself. The near uniformity of the universe, the evenness of the ancient light, and the small ripples that would later grow into stars, all of these could be explained by that brief inflationary breath. But inflation may also have left something else behind, a memory of imbalance, a hint of asymmetry, perhaps even a pull. Some cosmologists now wonder whether the phenomenon we call dark flow could be a lingering echo of that first expansion. If inflation happened unevenly, or if different regions of the early universe expanded at slightly different rates, then somewhere beyond our horizon there might exist other bubbles of space-time, other universes whose gravity still reaches across the boundary, tugging at ours. It's a strange image. Multiple cosmic spheres inflating side by side like soap bubbles in a cosmic sink, each containing its own physics, its own rules of light and matter. Some might have collapsed. Others may have grown forever. Our own could be one bubble among countless others, expanding within a larger sea of reality that we cannot see, but whose waves still lap at our shores. The notion is more poetry than certainty, but that doesn't make it less meaningful. Inflation tells us that the universe, as vast as it is, might not be all there is, and that what we call nothing might simply be another kind of something just waiting to unfold. When scientists try to describe the timescale of inflation, the numbers become meaningless to our senses. So let's picture it differently. Imagine the entire history of the universe, from the Big Bang to now, as a single minute. Inflation would have taken place in the first fraction of the first second, so brief that if the universe were a song, it would have been the silent intake of breath before the first note. Yet that breath set the key for everything that followed. There's an elegance in that idea. The thought that all complexity, all structure, all galaxies and lives and thoughts trace back to a single expanding whisper. And perhaps, if the dark flow is real, it's not something new or alien tugging from beyond, but the universe remembering its own motion, the echo of that first, impossible expansion still rippling through its fabric. Of course, not everyone agrees. Some researchers see the flow as illusion, a mirage of statistics and noise. Others say inflation, though elegant, still raises questions of its own. What triggered it, what stopped it, and whether it truly answers the riddle of beginnings. In science, every answer becomes a doorway to another question, and that's part of its beauty. The universe is less a solved puzzle than a symphony that never quite ends. Still, it's hard not to be moved by the imagery of it all, the universe swelling faster than comprehension, time itself stretching like warm taffy, space cooling as it expanded, light slowing its rhythm to form the atoms that would one day compose everything. In that sense, inflation is not just a theory of physics, it's a story of birth, told through the language of unfolding. When you step outside on a clear night and look up, you're seeing the aftermath of that breath frozen in motion. Every star, every cloud of gas, every glimmer of light is part of the cooling wake of that first expansion. You are literally surrounded by the afterglow of creation, and within you the same forces of balance and asymmetry that shaped galaxies once shaped the atoms in your body. So perhaps the inflationary ghost is not only out there, pulling galaxies through the dark, it is also within us, the same restless push that makes us wonder, imagine, explore. We are, after all, fragments of that same expansion, still unfolding, still reaching outward, and as the cosmic tide continues, whether driven by gravity, dark energy, or something more mysterious still, we drift along its surface, small, luminous, aware. The edge that pulls is also the breath that began, the silent expansion that turned nothing into something, and something into all of this. If we linger at this edge of possibility long enough, we begin to hear a second kind of voice, a quieter one, not of wonder, but of caution. Every mystery invites both believers and doubters, and the cosmos, being endlessly patient, listens to them all. The story of the dark flow and the ghost of inflation is no exception. For every hand pointing toward a hidden current beyond the stars, there is another raised gently, saying, "Perhaps not." Science, after all, is not a single song, but a harmony between curiosity and skepticism. One side imagines what might be, the other asks what can be known. Without both, discovery drifts too easily into dream. In the years after the first whispers of the dark flow were announced, a new set of eyes was turned toward the same sky. The Planck satellite, a European observatory launched in 2009, carried instruments far more sensitive than those before it. It too studied the ancient glow of the cosmic microwave background, the faint radiation left from the first dawn. But where earlier surveys had seen a subtle drift in that light, Planck's careful gaze found stillness. The galaxies, it seemed, were not flowing after all, or if they were, their motion was smaller than the instruments could see. The results puzzled everyone. How could one map show a current and another show calm seas? Was the earlier pattern an illusion, or was the new stillness simply a finer lens filtering out the faintest of whispers? The debate that followed was not a quarrel, but a conversation. Scientists on both sides studied and recalculated, testing every assumption, every line of code. They checked for noise, for bias, for the gentle distortions caused by the way telescopes read warmth and shadow. Some argued that the first data had been stretched too far. Others suggested that the effect might still be real but weaker, woven too faintly through the background for even Planck to catch. What emerged wasn't a conclusion, but a deeper understanding of how fragile knowledge can be when it leans over the edge of the unknown. Measuring the motion of galaxy clusters through the afterglow of the universe is like listening for the flutter of wings in a hurricane. Every signal is subtle, every interpretation a balancing act between belief and restraint. Yet, in this uncertainty, there is beauty. The skeptics remind us that not knowing is not failure, it is fidelity to truth. Science thrives on doubt, because doubt is how we make sure our light is real and not reflection. One astronomer compared the process to listening for wind in a place where air itself might not exist. You lean close, you listen hard, and even if you hear nothing, you still learn something. The texture of silence, the patience of space. Planck's silence didn't end the story of the dark flow. It simply deepened it. The idea remains like a note suspended in a symphony, a possibility neither resolved nor dismissed, and perhaps that's fitting. The universe has always kept some of its secrets slightly out of reach, as if to remind us that discovery is not a conquest but a conversation. When you look at the cosmic microwave background map, the subtle speckling of temperature and colour that represents the oldest light we can see, it looks almost like skin. Smooth, delicate, slightly uneven. Each tiny variation tells us about density, heat, gravity, about the way energy flowed when the universe was young. It's astonishing to think that such faint differences, measured in warmth too small for our bodies to sense, contain the entire history of structure and motion. Yet even there, even in that intricate pattern, the biggest mysteries remain unseen. The skeptics of the dark flow invite us to focus instead on what we do know, that the universe expands in all directions, that space and time themselves stretch like fabric, that gravity bends light, shaping what we see. They remind us that certainty is rare and that humility is the truest lens we have. For if the cosmos has taught us anything, it's that even our best instruments are still made of questions. And so the dialogue continues. One group points towards Centaurus and Hydra, saying, "There is motion there, something pulling." Another shakes their head softly and answers, perhaps only coincidence, or noise. Between them lies the quiet field of data, and above them the eternal sky, silent, impartial, patient. In a way, this is how knowledge grows. We build not by stacking certainties, but by layering questions. Every new telescope, every mission, every late-night recalibration in some lonely observatory adds another brushstroke to our picture of reality. Some strokes are bold, others faint, but together they form a portrait of understanding that is forever unfinished. There's comfort in that incompleteness. It leaves room for wonder. Imagine if every mystery were solved, every equation balanced, every question answered. The sky would still be beautiful, but it would no longer invite us to dream. The dark flow may turn out to be nothing more than a statistical mirage, or it may one day be proven to be the first faint trace of other universes touching ours across the cosmic horizon. Either way, the act of looking, of measuring, of wondering is what matters. It's how we remind ourselves that curiosity is not a flaw of humanity, but its most luminous trait. In the quiet between discoveries, science often feels like holding your breath. You listen, you wait, you check and recheck the numbers, not because you doubt the universe, but because you respect it. And when the silence remains, you realize that the silence itself is a kind of answer, that the cosmos has chosen for now to keep this one for itself, so we let it rest. We listen anyway. The hum of the microwave background continues to bathe the sky, soft and even, a lullaby of ancient heat. The galaxies drift, the stars shine, and somewhere, perhaps, the current still moves beyond the edge of sight. Science thrives not on certainty, but on wonder, the willingness to lean into the dark and ask again. That is its quiet faith, that the unknown is not a wall, but a doorway. And beyond that doorway, the universe waits, patient as always, holding its breath until we are ready to listen again. If we stand quietly now, at the edge of everything we've seen, the galaxies drifting, the whispers of ancient light, the fading of the Voyagers, we might notice a question rising softly through the silence. If the universe stretches on forever, what shape does forever take? It sounds simple, almost like a riddle a child might ask, but it's one of the oldest questions science and philosophy have ever shared. What does everything look like from the outside? The trouble, of course, is that there may be no outside. We're inside the fabric itself, woven into its texture. Yet still, we can ask, we can imagine. For centuries, thinkers pictured the universe as flat, like an infinite plane extending endlessly in every direction, a cosmic sheet without boundaries. Others imagined it as curved back upon itself, a vast sphere where travelling far enough in one direction might one day bring you back to where you began, like sailing around a planet too large to grasp. And still others proposed a stranger possibility, that space curves the opposite way, like the inside of a saddle, forever expanding faster than it can fold, opening into shapes that defy easy intuition. Today, cosmologists still describe these three possibilities, though in gentler, modern language. The first, the flat universe, is the one most of our measurements favour. It is simple, balanced, elegant. Light travels in straight lines. Parallel beams never meet. In this kind of cosmos, you could go on forever and never circle back, though forever itself might still be expanding beneath your feet. Think of it as an endless calm sea, its surface stretching evenly beyond every horizon. A universe like this feels infinite but steady, unfolding with the quiet assurance of something that has no end and no edge. The second shape, the closed or spherical universe, feels more intimate. In this version, space is curved gently inward, like the surface of a globe, though we can't perceive the curvature because we're too small within it. If you were to travel in a perfectly straight line long enough, you might, in theory, return to your starting point, though no traveller could ever survive the scale of such a voyage. The imagery is beautiful, though. Light looping endlessly, paths reconnecting, existence folding back upon itself like a self-embracing thought. In this cosmos, beginnings and endings are not opposites, but neighbours. The third, the open or hyperbolic universe, is the wildest of all. Here, space curves outward, expanding faster and faster the further you go, like a breath that never exhales. Imagine trying to walk up the inside of a bowl that keeps deepening as you climb. In such a shape, even light itself spreads thin, stretched as it travels, red shifting into ever longer waves until its colour fades beyond sight. It's a universe that races away from itself, never to meet again. A cosmos of eternal divergence, beautiful in its melancholy. Each of these shapes tells a different kind of story. A flat universe speaks of balance, of steady creation and quiet expansion. A closed one suggests rhythm and return, a cosmic heartbeat that might someday reverse, drawing everything inward again. And an open one tells of endless flight, of time stretching so far that even memory becomes light years apart. Our current understanding leans gently toward flatness. Observations of the cosmic background light suggest that on the larger scales, space doesn't curve much at all. Yet even that answer leaves room for wonder. Because flat doesn't mean empty. It simply means that the geometry of the universe, as best we can tell, is in perfect balance, neither falling in on itself nor opening too fast. Like a coin balanced on its edge, it hovers between two destinies. If that balance holds forever, the universe will keep expanding, stars will burn out, and everything will grow dimmer but never quite stop. The night sky will thin, galaxies will drift apart until each becomes isolated in its own pocket of darkness. Trillions of years from now, even starlight will fade into whispers of heat, a faint glow spread evenly across space. It sounds lonely, but it's also peaceful, the final exhalation of a cosmos that has given all it could. And yet, there's something oddly comforting in that vision. A flat universe stretching endlessly is a universe without walls. It means that there is always somewhere further to go, always more light waiting to be discovered. It suggests not confinement, but freedom. The horizon may move away faster than we can chase it, but the act of chasing still fills the story with meaning. The curved universes, closed and open, offer other comforts. The spherical one tells us that nothing is ever truly lost, that what departs may, in some deep way, return. The hyperbolic one reminds us that there are infinities even within the infinite, that the cosmos itself may have layers of endlessness, each receding like reflections in a hall of mirrors. In one, we are travellers destined to come home. In the other, we are explorers destined to never stop. Perhaps that is the real answer, that the shape of forever depends on the way we move through it. The scientist measures curvature and density. The dreamer measures wonder and time. Both, in their own ways, are right. The universe curves not only space, but our sense of belonging. If you could float outside the Milky Way, though there is no true outside, and look back at it curling in its spiral, you might notice how it already resembles all three shapes at once. Its arms stretch flat across the plane, its centre curves in on itself, and its edges spin outward into darkness. The cosmos, it seems, refuses to choose. It contains every geometry in a single dance. When we gaze upward, we participate in that dance. Every photon that reaches your eyes bends slightly as it travels, shaped by the gravity of galaxies and the swelling of space. Even your sight line to a nearby star follows a subtle curve through time. We live inside geometry, and geometry lives inside us. So, perhaps the shape of the universe is not a question of lines and angles at all, but of rhythm. The rhythm between expansion and return, between isolation and connection. Every heart that beats, every orbit that turns, every wave that rises and falls, echoes that larger pattern. We're tiny, yes, but we carry the same symmetry in our blood. As we drift toward the close of our journey, it feels fitting that the universe's final secret is not a number, but a shape, and not a fixed one, but a living one. Something that changes as we learn, bends as we dream, and continues beyond every horizon we draw. In the end, forever may not be flat or curved or open. It may simply be awake. And so, we arrive at the edge once more. Not the edge of a galaxy or a star, not even the edge of the universe we can see, but the softer edge between knowing and mystery, between thought and rest. Every journey, even one through eternity, needs a quiet place to end. Or perhaps, as the universe reminds us, endings are only pauses before the next unfolding. If you look back over all we've seen, The path feels less like a straight line and more like a spiral of light curling inward on itself. We began at the glittering heart of our own cosmos, the sharp new eyes of the James Webb Space Telescope, revealing the first dawns of starlight. We drifted through Hubble's painted skies, where colour became memory and memory became meaning. We glided beyond Neptune into the silent frost of the Kuiper Belt, where the remnants of creation still sleep in their crystalline shells. We followed the Voyagers as they crossed the breath of the sun and stepped into the interstellar dark, carrying with them the laughter and heartbeat of humanity pressed into a golden disk. We felt the pull of something unseen, the dark flow, the inflationary ghost, and listened to the silence that followed. And finally, we looked at the possible shapes of forever, tracing the curve of everything we could imagine. Now the trail bends again, and the question becomes softer. What lies beyond all of that? Not in the measurable sense, no numbers, no coordinates, but in the feeling of it. The moment when light ends and darkness begins again. It might sound strange to speak of darkness as a beginning, but perhaps it always has been. Long before there were galaxies, before even the faintest spark of hydrogen, there was a darkness full of potential. Physicists call it vacuum energy or quantum possibility, but those are just words for a silence rich with promise. From that stillness came the first expansion, the first flicker of light, the first breath of time. Maybe that means the darkness wasn't the absence of anything, but the waiting for everything. Every frontier we've reached has carried that same rhythm. The Webb telescope opened its golden mirrors not to see brightness, but to study what lies hidden within shadow. Hubble looked at black patches of sky and found them teeming with galaxies. The Voyagers crossed the outer night and discovered that even the void between stars hums faintly with plasma's song. Again and again, darkness reveals itself not as emptiness, but as the prelude to discovery. The universe, it seems, is built on this gentle balance, illumination and obscurity, knowing and not knowing. We look outward and see light, but we understand it only because of the dark around it. Night gives meaning to day, silence gives shape to sound, stillness gives weight to motion. It is the same with knowledge. Every truth we uncover casts a new shadow, an unanswered question stretching just beyond reach. If you close your eyes for a moment, you can feel that pattern inside yourself. The pulse of your blood, the rise and fall of your breath, these are echoes of cosmic rhythm, expansion and contraction, warmth and coolness, awareness and rest. We are small, yes, but we move to the same invisible beat as galaxies. The atoms in your body were once part of a star that lived, burned and died billions of years ago, sending its elements into space so that one day they could become you. You're literally made of stardust, arranged into thought. The cosmos has found a way to look back at itself and wonder. And maybe that's the most beautiful thing of all, that the universe, for all its size and strangeness, became self-aware through us, through eyes that gaze upward at night, through minds that dare to ask what lies beyond. We are not separate from the stars. We are the way the stars have learned to dream. When we imagine the end of the universe, we tend to picture silence and darkness, as though the light simply goes out. But perhaps the truth is gentler. Perhaps when the last stars fade and the galaxies drift apart, what remains is not emptiness but continuity. A calm so perfect that even time rests. A return to the same dark potential that began it all. In that stillness, the seeds of a new creation may already be stirring. The cosmos, after all, has always known how to begin again. And so, as we come to the close of tonight's journey, we return to the quiet. You might picture it as sitting beside a campfire that has burned low, its embers fading to red beneath the ash. Around you, the vast night stretches endlessly, but but it no longer feels cold. It feels alive, aware, as if listening. The universe does not end in silence. It ends in attention. Every frontier becomes a horizon again. Every question opens into another. And maybe that's why we never truly reach the edge of everything, because the act of wondering creates new light to follow. We chase the unknown, and the unknown grows, unfolding like a dream that expands as you try to describe it. That's the quiet miracle of existence. The more we see, the more there is to see. If you listen closely, you can almost hear it now. The faint echo of the golden record spinning somewhere beyond the heliopause, its grooves still carrying the laughter of Earth, the sound of rain, the music of human hands across strings. Perhaps it will play forever, in some slow cosmic rhythm, its notes blending with the plasma hum and the deep background of the universe's first light. It is our lullaby to the stars, and maybe to ourselves. A reminder that even across eternity, beauty is worth sending. And so we end here, not with an answer, but with stillness. The telescopes will keep watching, the probes will keep drifting, and we, tiny observers on a small blue world, will keep listening. Somewhere the darkness begins again, not as an ending, but as another invitation. Thank you for being here, beneath the same starlight, in this shared breath of curiosity. Whether your eyes are still open or already half asleep, may this quiet sense of wonder stay with you. For tonight, the universe can rest, and so can you. Sleep peacefully, dream deeply, and remember, even the darkness is part of the light.